Okay, so in this video, I'm going to go through another past paper question. This time it's looking at a pseudocode listing. And the first part, well, I'll start by reading the question and we'll go through it step by step. Okay, so this is, an algorithm has been written in pseudocode to check if a new password is in a list of previously used passwords. And that has the identifier old list. Okay, and we can see there that it's a list of items, of elements. If the password is not found, the new password will be stored at the end of the list to replace XXXX, which is already stored there. Okay, so I'm going to skip past the listing just for a second, looking at the question. So the first part of this question is to identify 3 errors in the pseudocode. Okay, so once we've got clear in our head what the algorithm is trying to do, we're taking the user input, the new password, and we're comparing that with each item in an array or a list, and if we find it, if there's a match, then we return a message saying that there's a match, it's already been used. And if we get to the end of the list and we haven't found the password that's been entered, we haven't found a match, then we store the value in the list at the end of the list. Okay, so essentially this is really iterating through a list. Okay, so we've got to spot the mistakes. There's 3 errors in this code. So line 1, output, enter your new password. So this will give the user a message, tell them to enter the password. Input new password. Okay, well that seems okay so far. Set the position variable, I'm assuming posin is position, to 1. Okay, so we're starting at 1. Okay, right. Found we set to false. Okay, so that's going to be a Boolean data type. And then we get into a post condition loop, this repeat until here. Okay, so we post condition loop, we've got the condition here. Okay, so we're repeating if the password is equal to old list position, so it essentially will compare, in this case, the new password. Well, I think I've spotted the first error. We've got if password, and the variable up there is called new password. So error number 1 is on line 6. Password. And the correction would, of course, be that it should be new password. Oh, I can't spell. Okay, so if new password is equal to old list position 1, then set found to true. If not, we increment the position. I say posin makes sense. It's position number. We increment pos n, and then we end the if, and then we get to the condition. So we're saying is found true and old list position. Well, that doesn't make sense because we want to check if found is true. Okay, or have we got to the end of the list? So this shouldn't be an and, this should be an or. So 11, line 11, and should be or. Okay, because we want to break out of this loop if either we're at the end of the list, which is this second part of the condition, or we found a match to the new password already in the list. So that definitely should be an or. Okay, if found, then output. So found is true. We output that error message. That makes sense. Else input network new password accepted. Well, that should be output. That's an output message, isn't it? So the third problem is line 16. It's got input, and it should be output because we're outputting a message. Okay. So there we found the 3 errors in that list. So I'm just going to tidy this up a little bit, get rid of my scribblings. Okay, hopefully that made sense, where those errors were and how to do it. Remember, it's important to have a clear idea of what the algorithm is supposed to be doing, and then just tracing through really the pseudocode listing. Okay. So if we output new password accepted and old list position, we slot in the new password, which would be where we get the position would be at the end of the list, because if found wasn't true, to have broken out of the repeat, the repeat, we would have had to have the old list position would be equal to the 3x, that placeholder, that 4x placeholder, and so the position would be at the end of the list. So we would replace that placeholder with the new password that's been input by the user. Okay, let's move on to the next question. So, next part of the question, complete the flowchart for this corrected algorithm. Okay, so first of all, let's go back, and we've got the first thing that happens, output, enter your new password. So the symbol for input output is a parallelogram, and so we put output. I'm going to zoom in so I can write this. I should have made that bit bigger. Output, and what was it? Enter your new password. Okay, and then the next part of the list was input. So we've got, join that up. Okay, add the arrow indicating the flow. Okay, and again, because this is input output, and this time it's input, and what we put in, we're inputting the new password. Okay, and then next on the list, and you see I'm basically just following really a set position. Well, I'm setting those variables. I can do that both in one. Now this is initialization. This is sort of an action, if you want. Oh. Okay, so I put that in a rectangle. Okay, and I set POSN to 1, and it was found to false. Okay, then. Right, now here we've got that loop. Now in flowcharts, we really want to show, we want to skip really to this condition. Okay, so because of the way flowcharts work, really, we've got a decision. We say, is the new password in the list? Okay, so that's what we need to check. We need to check if the password is in the list. Then we set found to true. Otherwise, we increment. Okay. So that's what we're checking first. So we're saying, is new password equal to And was it old list? Old list. Old list equals old list and position 1. So I need to move this down because I've not given myself enough space to stick. Wait, that should do it. Oh, hang on, need to draw. Okay, and because this is a decision, it goes in a diamond shape or rhombus. Now we've got two possible options. Okay, it's either true, so we put yes, path, or false, and we put no. Okay. Right. If it's yes, we set found to true. Okay. If it's no, we increment position. Pause n. Pause n plus 1. Okay, again. Alrighty. Now, if we then need to check whether or not we want to loop around again, because if we've either found it or we've got to the end of the list, then we need to break out of the loop. So we've got to say is found. Just check that, is it? Is found or is found or old list POSN equals 1, 2, 3, 4, which means we've got to the end of the list. If either of these are true, then we break out of the. This is not the best drawn flowchart ever, but I think it serves its purpose. I can't go ahead with that. That's horrible. I need to tidy that up because to my eyes it's painful. So let's try that again. Try and make that look slightly tidier. Okay, right. So and this here needs to come in and join here. Okay, because we need that. We need this this updated found to be updated if the item has been found before we get to. Let me just. Before we get to this decision, okay? So this line here needs to join, come around and come into the flowchart before this decision is made, okay? So if neither of these are true, we go back around. So we go back around up here, and this is how we create that loop in flowcharts. Okay, so we've got those here. All right, making sure that the flow is clear. Right. Now, if these are true, then we what do we have to do? We have to output password has been used before. What do I have to check first? No, it's found true. If we're breaking out of here, we need to say is found true. So I'm going to zoom right in because I'm running out of space here. Found true. is found true. Okay. If it is, then we output. Put that up. We output our message to that effect. Output password. I think its password has been used before. Okay. If not, so if found isn't true, then we need to update the password. So we have the old list. We have an output, I believe. Let's just look back. So we output new password. So output new password accepted. Okay, and this again goes in a rhombus. And then we update the list. And this is, so we've got old list POSN, and that is updated to the new password. Okay, and this is an action, so we stick it in a rectangle. I should have planned this a bit better. And I just need to bring this around just to tidy everything up. And so if found is true, we output the message here. So if found is true, we output the message, and then we follow this to here to stop. Okay, and so that is how we complete the flowchart part of this question. I hope that's been useful. And if you don't have any questions, queries, doubts, or want me to do any other particular questions, just let me know in the comments.